You are welcome back from break. Let's continue from where we stopped. We now come to another aspect under the differential calculus, and which I call gradient of a function. What is the gradient of a function? Given that y equals 2x raised to the power 3 minus 4x plus 7, gradient function is dy dx, which is 6x squared minus 4. That is the gradient function. Therefore, if we are to find the gradient at a particular point of x, we slot that value of x into this gradient function to obtain our gradient. Do you understand? Let's take example from the UTME past question. Now let's take this example 1 for gradient of a function. Find the gradient of y equals 2x raised to the power 3 minus 7x raised to the power minus 2 at x equals minus 1. We are to find the gradient function first. The gradient function is the dy dx, the change in y with respect to x, and that is 6x squared 3 times 2, that is 6, then x raised to the power 3 minus 1, just as illustrated at the beginning, minus 7 times minus 2, that is plus 14, x raised to the power minus 3. You know, minus 2 minus 1, we have to subtract 1 from the power negative 2, which gives negative 3. This is the gradient function. So at x equals minus 1, that is where x equals to minus 1, we now substitute x equals to minus 1 into this gradient function to obtain our gradient. Indeed. So it will now be 6 into minus 1 all squared plus, 14x raised to the power minus 3 is written as 14 over x raised to the power 3. Do you understand why? Or I should explain briefly. Let me explain briefly. Anywhere you see something like 3x raised to the power minus 2, it's the same thing as 3 times x raised to the power minus 2. 3 times, you express x raised to the power minus 2 as 1 over x squared, and this is over 1. 3 times 1 is 3. 1 times x squared is x squared. So you have 3 over x squared. So anytime you see 3x raised to the power minus 2 is the same thing as 3 over x squared. The same thing applies to this. 14x raised to the power negative 3 is the same thing as 14 over x raised to the power 3. Now, substituting the value of x into it, we have, this is 6 into 1, because negative 1 squared, when you raise a negative value to power 2, it gives you positive, so it's 1. It will be 1 back, plus 14 over negative 1 all raised to power 3. But when you raise a negative value to an odd power, your result will eventually be negative, just like this. Power 3 is an odd power. So when you raise negative 1 to this power 3, you will get negative 1 back, because negative must be the result. 6 plus 14 divided by minus 1. So we now have 6 plus 14 divided by minus 1 is minus 14. That is 6 plus minus 14, which is minus 8. 6 plus minus 14 gives minus 8. And that tallies with option A. Option A is the correct answer. Let's consider example 2. If the gradient of y equals 2x raised to the power 4 minus px raised to the power 2 plus 4x at x equals negative 2 is negative 40. Find the value of p. What we mean is the y, the x will be equal to 8x raised to the power 3 minus 2px plus 4, and it is equal to what has been given before, and it is equal to minus 40. at x equals minus 2. That is, if we can supply the x equals minus 2 into this gradient function, it is equal to 40, minus 40. So that is 8 into minus 2 raised to power 3 minus 2 into p into minus 2 plus 4 equals negative 40. Negative 2 raised to power 3, that is negative 8. Times 8, that is negative 64. Negative 64 positive 4p plus 4 equals negative 40. Negative 2 times negative 2 gives positive 4. That is why we have positive 4p here. So here we have 4p equals negative 40 positive 60. This is what I do. Negative 64 plus 4 gives negative 60. That negative 60, by the time we take it across the equality signs to the other side, it becomes positive 60. Do you understand? The negative 64 plus 4 gives negative 60. That negative 60, when we take it across the equality sign to the other side, it becomes positive 60. So we have 4p equals positive 20, because negative 40 plus 60, that gives positive 20. Dividing both sides by 4, p be equal to 5. So the final answer is option B. Here we come to another concept yet under differential calculus. It is derivative of product function. Derivative of product function. What do I call product function? Function like this, where we have two terms multiplying each other. Product. This bracket multiplying this bracket. That's a product. So function like that is called product function. How do we differentiate a function like this? If y equals 2x plus 1 in bracket into 5x plus 2 in bracket, find the y dx. That is a jam pass question. What are we expected to do? I want to give you a straightforward. This is not WAEC. This is not theory approach. I want to give you jam approach. This is not a situation whereby you're using the formula you have crammed. That formula, oh, this product formula. No. It's not the time. There is no time. You don't have luxury of time to do that in jam. This is all you need to do. The y, the x, that is changing y with respect to x, will be equal to, well, for the purpose of explanation, I will do the first one with little long process. The next one, I will not allow you to waste any time. I just tell you what to do. But let me do the first one like this. 2x plus 1 complement into 5x plus 2 plus 2x plus 1 into 5x plus 2 complement. When you see it like this, what we mean is differentiate these brackets. This bracket that I put complement on means to be differentiated. Differentiate this bracket, use the result to multiply the next bracket. Plus, use this bracket to multiply the derivatives of the next bracket. Do you see what I have just done there? Differentiate this, use the result to multiply this. Then alternate it now. Differentiate this, use the result to multiply this. And that's what we do. So what's the derivative of this bracket? That's 2. That is, you have to differentiate 2x plus 1. You have learned a lot of that in the previous examples. When you have to differentiate 2x plus 1, differentiation of 2x is 2. Differentiation of 1 is 0 because it's a constant. So, into just multiply this, that's all, plus differentiate 5x plus 2. The derivative of that, the result of differentiation in this is 5. Because when you differentiate 5x, you get 5. Differentiate positive 2, you get 0. So, 5 times 2x plus 1. That's it. Differentiate this, use it to multiply this. That is what we have done. Now, open this bracket. So, we have 10x plus 4. We have 10x plus 5. 10x plus 10x, that is 20x plus 9. And that is the answer. The correct option there will be option B, 20x plus 9.